These are notes for Honors Math 3, Unit 6. We're starting on conic sections, and in this unit we'll be studying parabolas, circles, ellipses, hyperbolas, and hopefully half conics. Objectives 1 and 2 are going to cover parabolas. We're going to be working with their equations, writing their equations, as well as finding the characteristics of a parabola. So I've labeled all the parts here that we'll be focusing on in this unit. So we'll start with the vertex, which is HK, and we get that from our equation. After that, a parabola is actually defined by two things, a focus and the directrix here. So the focus point is located inside of the parabola, the directrix outside of the parabola. You'll see your axis of symmetry here running vertically. It is dividing the parabola into two symmetric pieces, and it runs through the vertex. The focus also lies on the axis of symmetry. The directrix passes through it and is perpendicular to that axis of symmetry. Okay. To find the focus and the directrix, we use something called C, which is the focal length. The value of C is given by 1 over 4a. Keep in mind that a can be positive or negative, but my focal length C is always positive. So that distance is from the vertex to the focus or the vertex to the directrix, and that's how we'll locate those things. The last thing is the focal chord, which runs through the focus and is parallel to the directrix and has endpoints on the parabola. Sometimes we're asked to find the length of the focal chord, which is given by 4 times C, the focal length. And then sometimes we're also asked to find the location or the coordinate pairs for those endpoints. Okay? So I'm going to label our sideways facing parabola now. I'm going to start with our equation. And you'll notice first that we swap x and y as well as h and k, since x is always grouped with h and y is always grouped with k. The vertex is still always going to be hk. My axis of symmetry should run through that. This time the axis of symmetry is going to be a horizontal line. Last time, since it ran vertically through the vertex, the equation of the axis of symmetry is given by x is equal to h, since that is the x value of the vertex. This time, it's a horizontal line, so it takes on the form y equals, and since it passes through the vertex, it has a y value of k. Right, inside, we'll have our focus. Outside of that, we'll have the directrix. Again, it runs perpendicular to the axis of symmetry, so this time the directrix is vertical. And then we still have the distance between the vertex and the focus. C, vertex and directrix. Also C, which is still the focal length given by 1 over 4a. And we can also add in the focal chord here, which is parallel to the directrix and runs through the focus point, has endpoints on the parabola. All right, so what we're going to work on today with 6.1 is identifying those characteristics, namely the vertex, focus, directrix, and axis of symmetry. We'll work on sketching, but first we're going to work on getting each equation into that standard form. So our first example here is y plus 2 squared equals 4 times x minus 3. To get this into its standard form, we just want to identify which value we should be isolating. So do I want an x or y equals? Well, since x has a power of 1, and y is squared, we want to get x by itself. So to do that, we're going to start by dividing by 4 to the other side. And then we'll add 3. This is our standard form, so we can pick out x equals a, y minus k squared plus h. So the main thing I can pick out from this is the vertex, and that's one of the things I have to identify anyway. So my vertex here, remember h is outside this time with x, k is always grouped with y. So h is 3, k is -2. You might also note which way this is opening. So like with my parabola facing up and down, if a is positive, we're pointing up. If a is negative, it's reflected over the x-axis and points down. Here, when a is positive, my parabola is opening to the right, and when a is negative, it opens toward the left. So in this problem, since it is x equals, and my leading term is positive 1/4, it is going to open to the right. So we can sketch as we go. So let's add on our vertex. So 3, -2. That 1/4 does make the opening change just a little bit from a normal width. So if we want, we can plug in a number for y, and it looks like 0 would be a nice number. So if we plug in 0 for y, we end up with 2 squared is 4, 1/4 of 4 is 1, plus 3 is 4. So there's the point 4, 0 that we can plot. So it is opening from our vertex here to the right. And you can use symmetry to help you generate the other point. So if we went to 4, 0, we should also get 4, -4. And we can check that. If you plug in -4, -2 squared again is 4. So we'll end up with 4 again. All right, so there's our picture. Let's keep going with identifying the characteristics. So besides the vertex, the axis of symmetry might be the next easiest thing to identify. So it's running horizontally through our parabola and has a value of y equals. Since it passes through the vertex, it takes on the y value of the vertex, y equals -2. To find the focus and the directrix, the focus, remember, is a coordinate pair. The directrix is the equation of a line. But to get to those things, I first need to know the value of c, which is the focal length. So c is the distance that we'll use to go from our vertex to each of those things. So in this problem, 1/4a, where a is 1/4, this becomes 1/1, which is 1 unit. So this is my focal length, which we'll use to find the focus and directrix. So from our vertex, we want to go 1 unit inside of our parabola, 1 unit in to find the focus. And so that's at 4, -2. To find the directrix, we'll use 1 unit in the opposite direction. So right to get to the focus, left to get to the directrix. Remember, it's not a point, it is a line that is perpendicular to my axis of symmetry. And so that takes on the form x equals 2. If we wanted, we could find the focal chord and its length, the endpoints on the parabola here. So remember that the focal chord length is 4 times c. That would be 4 times 1, which is 4 units. It passes through the focus and is parallel here to my directrix. So I actually have it right here already plotted out. The points I used to graph my parabola end up being those endpoints. Since 2 units up from -2 would take me to 4, 0, and 2 units down from the focus would take me to 4, -4. So I can find the focal chord endpoints at 4, 0 and 4, -4. All right. On example 2, we're going to be working with a y equals x squared. So we want to get y by itself, but I do need to complete the square for the x terms. So I want to isolate the x terms here. Leave a little space for completing the square. We'll subtract y and 18 over to the right. So hopefully you remember we're looking for a constant whose product of itself, a number times itself is this value here, and a number, that same number plus itself is 10. So shortcut for this, half of 10 is 5, and 5 squared is 25. So that's the value that we're looking to add in here. That will complete our square, so we balance add 25 over here to the right as well. What it does is allows us to factor the x values just like it did over here. This was a y plus 2 squared, so I'm looking for that to happen over here. This gives me x plus 5 squared. On the right side, I have negative y plus 7. To get y by itself, we'll subtract 7 and then divide by the negative 1. So remember to divide all the terms by the negative. So this is now negative x plus 5 squared plus 7. And that is going to be our standard form. Since it's a y equals parabola, it should be opening either up or down. Since the leading term is negative, our parabola will be opening down. Let's start with the vertex. HK, negative 5, positive 7. All right, and from here it is opening down, so if I'd like to find some nice coordinate pairs, I could really just use the fact that it has that normal width opening. So I know when I plug in negative 4, it is going to be here at 6, at negative 6, also at a height of 6, and so on. So about like this to give me my parabola. It will eventually run into and cross the x-axis twice. So let's work on the axis of symmetry. Running through the vertex. This time, though, it's a vertical line. X is equal to, so the x value of the vertex, negative 5. For the focus and the directrix, we first need to find our focal length C, 1 over 4a. Now, although a is negative, I don't want to use the negative since focal length is always positive since it is a length. And so we'll just use the value of a as 1. And so this is 1/4. So we're going to use 1/4 of a unit from our vertex into the parabola to find the focus. So about here. So the coordinate pair, I'm here at my vertex, and we went down 1/4 unit. Down affects the y value, not the x value. So 7 minus 1/4 is 6 3/4. So the focus is going to keep the same x value as the vertex. And we subtract 1/4 from 7 is 6 3/4, or we can write it as 6.75. For the directrix, we want to use 1/4 in the opposite direction, down to get to the focus. We're going to go up to get to the directrix, up 1/4 of a unit. This line should be perpendicular to my axis of symmetry. So if I was up at 7 and I just went up 1/4, we're now at 7 1/4. This is y equals 7.25. So those are the characteristics that we're looking for here. Instead of looking at the focal chord in this problem, I want to remind you that sometimes we'll need to find the x-intercepts. So let's solve for the x-intercepts by letting y equals 0. So we're going to set our equation equal to 0 here. All right, so we have negative x plus 5 squared equals negative 7. We can divide both sides by the negative. When we square root both sides, remember that to square root, x plus 5 squared gives us the absolute value of x plus 5 is equal to root 7. That means that x plus 5 is equal to plus and minus root 7. And then we subtract 5 over. Negative 5 plus or minus root 7. So not only can I do all these new characteristics, I can also find something that I've worked with before. And that ends our notes for Objective 1.